So the next question we have for today is from section 6.3, number 17. And basically it wants us to revolve the graph of y equals square root of x and y equals x cubed about the x-axis. So you draw a graph to basically get a picture, and as you can see, this here is the graph of y equals square root of x, and this here is the graph of y equals x cubed. So you have to find where these two graphs intersect by setting the two y's equal to each other. So if you know y equals square root of x and y equals x cubed, you're going to get square root of x equals x cubed.
That's not true.
And the only logical places that these two graphs can intersect are 0 and 1.
That is true.
So when these two graphs intersect, x is at 0, and then the second point, x is at 1. So that's how we get our intersection points, which will also be our limits of integration. So we go ahead to set up the integral by the shell cylindrical method. And this goes by v equals 2 pi times the integral of the radius. Since we're revolving about the x-axis, the radius is going to be in the y-axis. So y is the radius because we're revolving about the x-axis, not the line y equals 2 or y equals -2, just the x-axis, y equals 0. So the radius is going to be y times the equation on the right minus the equation on the left. The equation on the right is y equals x cubed, but we have to put this function in terms of x. So basically we have to make y a function of x. So to do that, we take the cube root of this and we get x equals y dot. So that's the function to the right. And then the second one, we have y equals square root of x. To make x the function, we have to square this and square this. So y becomes a function of x, and that gives x equals y squared. So we're going to subtract this graph from this graph. So that gives us y to the 1/3 minus y squared times dy, the differential element. So the limits of integration is also going to be about the y-axis, which is from 0 to 1. So it goes 0 to 1. And then you can basically do the multiplication. From here it just becomes straight calculus 1 integration, 0 to 1. Y times this gives you y to the 4/3. Basically the same concept. Y times y this is y to the 1. So you have to add this up. 1 plus 1/3 equals y to the 4/3. Minus y times that gives you y cubed, and the differential element dy. So if you integrate this, you get, remember how to integrate. If you have y to the n, the value for the integral is going to be y to the n plus 1 divided by n plus 1. So basically this one is going to be y to the 4/3 plus 1 divided by 4/3 plus 1 minus y to the 3 plus 1 divided by 3 plus 1 from 0 to 1. So this equals, if you do this, you're going to get, you're going to get 2 pi times 3/7 times y to the 7/3 minus y to the 4 divided by 4 from 1 to 0. Just permit me to take this off the drawing so we can continue on this side. So this translates to 2 pi. We plug in the first limit of integration, which is 1, and that makes it 3/7 minus 1/4. And then the second limit of integration is 0, so that leaves this as 0. So if you work this out, you find out that V equals 2 pi times 5 out of 28, and that equals 5 pi over 14. So that's the volume we get when you revolve the area formed by the intersection of these two graphs about the x-axis using the volume by shell method.